welcome to our very first lesson of our flipped classroom. Alright, first of all, if this is in a study hall, make sure that you have already asked permission that you are looking up YouTube videos. You need to start off with your table of contents. We are doing lesson 2.1 today, which is relations and functions. So put your table of contents, or update your table of contents, and then go to the page that you'll be writing on today and give it a title. Our essential question today is, what is a function? Alright, throughout this, if the video is moving too fast for you, you need to make sure that you know where the pause button is and then the play button. So you will need to pause this at some times to be able to get down all of these notes. This lesson includes a lot of vocabulary, so we need to know the definitions of one-to-one, on-to, or both one-to-one and on-to. So go ahead and hit pause right here so you can copy down all of the highlighted information. We also need to know the difference between a discrete and a continuous function. A discrete function is made up of points or segments, whereas a continuous function is a smooth line or curve. Again, go ahead and hit pause. We need to be able to look at a graph and decide if it is a function, and we do this by using a vertical line test. So we imagine there's a vertical line going through the graph, and if you slide this line along the x-axis, will it ever touch the graph twice? In this case, no. But if I come over to this graph, there are 2 points where they touch, and therefore then it is not a function. So again, you can hit pause to get your notes up to date. Then we also need to know independent and dependent variables. And function notation, we will be evaluating functions with this. Again, hit pause. Okay, the first example that we're going to be looking at is looking at some points. We have to determine the domain and the range, decide if it's a function, and if it is a function, is it one-to-one, on-to, or both? So the first part, the domain and range. The domain is the x values. So remember, our points are listed as x, comma, y. So I'm going to be working from the left to the right, writing down all of my x values. So I have -4, -3, 0, 1, and 3. The range then is all of my y values. So I'll be working from the bottom to the top. So the lowest one was -2, 0, 1, 2, 3. Okay, now we have to decide if it is a function. To do a function, you draw a line, a vertical line, and then you decide, is this line ever going to hit 2 points at the same time? And the answer is no. So this passed the test, it is a function. Then we need to look at the one-to-one and on-to. So we start matching up our domains and ranges. -4 was matched up with 0, -3 with 1, 0 to -2, 1 to 2, and 3 to 3. So if we look back at our notes, every range has a value, so therefore it is onto. And there are no 2 domains that go to a common range. So this one is both one-to-one and onto. Alright, next example. We're going to be looking at some data, and we need to decide, whoops, sorry about that. Okay, we're going to be looking at some data and deciding if it is a discrete or continuous graph, and whether or not it is a function. So we're going to start by plotting these points. The years will go on our x-axis. The fuel efficiency will go on our y-axis. So go ahead and make an x-y axis. Then on my y-axis, I'm going to start at 20 and go up by halves. Now we go ahead and just make a scatter plot by putting points. So at 2001, I go up to 20.8, and so on. Now that we have our graph made, we have to decide whether or not it is a function. Again, we look at our vertical line test. Will this line ever intersect 2 points at the same time? No, so this is considered a function. And is it discrete or continuous? Remember, a discrete graph is made up of points or segments, so this one is a discrete function. Okay, we could also do this for equations. This equation, y equals 3x minus 1, is in the form of y equals mx plus b. M, again, stands for our slope. B stands for y-intercept. So to make this graph, we start with the y-intercept. You go to -1 and make a point. From there, you need to do the slope, which is rise over run. So we need to look at our slope as a fraction. 3 is 3 over 1 as a fraction. From that point, then we can rise 3 and run 1. So up 3 over 1. And we will connect this because this is an equation. Now we need to determine the domain and the range. The domain is similar to our vertical line test. We are going to draw a vertical line that will run along our x-axis, and we need to decide when will this line intersect the graph. So as we can see here, it's intersecting the graph. But what about when it's over here? Is this intersecting the graph still? And we know lines go on forever, so we can imagine if we extend out a line that they will eventually intersect. So it does not matter where we put our line, it will always intersect the graph. So this means that the domain is all real numbers. And that is a symbol that we can use for all real numbers. Now the range we work similarly with. This case though, we are going to do a horizontal line to run through the y-axis. And again, we need to determine when will this line intersect the graph. So we can see all through here it'll intersect the graph. But again, when it gets down here, will it intersect the graph? Again, we know lines go on forever, so yes, we know it will always intersect the graph. So this range is also all real numbers. Next question is it a function? Well, we already got a vertical line drawn. Let's use it again. Will this ever touch the graph twice at the same point? Answer is no, so this is considered a function. And then we look at one-to-one and onto. Well, since each domain has a unique range, it is considered one-to-one. And because there are no range values that are excluded from a domain, this is considered onto as well. So this is both. The last question asked in this problem is discrete or continuous. Discrete, again, is just points or segments. This is a complete line. It is continuous. The last type of problem we're going to go through is evaluating a function. F of x equals to x to the third minus 3 is the same thing as y equals x to the third minus 3. The reason we use function notation sometimes is that it's when we're working with multiple equations, we can call one the f equation, another one the g equation, another one the h equation, and it helps keep us organized. So f of x equals x cubed minus 3, we need to find f of negative 2. What that means is we're going to replace all of our x's with negative 2. So f of negative 2 will be negative 2 cubed minus 3. And always when we are substituting, it is a good idea to put the number that we substitute in parentheses. Okay, now we have to evaluate this function. F of negative 2 is negative 2 times negative 2 times negative 2. That's what negative 2 to the third means. So let's look at the 2 part. 2 times 2 times 2 is 8. And then the negative part. Negative times negative is positive. Times negative again is negative now. So it is negative 8 minus 3. So f of negative 2 is negative 11. And that is our answer. Now when we evaluate functions, we can find f of a variable as well. So this time we're finding f of 2t. So we're going to replace all x's with 2t. Okay, so now we have to think about what does 2t cubed really mean. That means 2t times 2t times 2t. So we can compute 2 times 2 times 2. We just did that in the last problem, which was 8. Then t times t times t is t cubed. At this point, we look to see, can we simplify this at all? Because one has a t cubed and the other term does not, this is as simplified as it can be, so this is our final answer. Alright, this is the end of lesson 2.1. So at this point, you need to make sure that you have your summary written, and then also go back and look over and write your questions. Make sure that if there are any questions about this lesson that you didn't understand, that you have them ready for class the next time I see you.